So at the end of last class, as I mentioned earlier, it seemed like there's a lot of information coming at you. Some people are getting a little confused, so we need to slow things down, maybe change the order I'm doing this. So we're talking about domain and range, which was what are the x values for the graph, what are the y values for the graph. And I said if you had a solid dot, that means that point was included. The line went right up to that point. If you had a hollow dot, it means the line stopped just short of that point. Okay? And if you had an arrow, that means the line went on forever. And there was two ways of communicating, we said. There was set notation that used the brackets, and we had interval notation that uses the inequality symbols, right? And to make things a little bit easier, I think today we'll do all set notations first. Once we've got a firm grasp on that, we'll come back and we'll do the interval notation. That way we only have to focus on one style, right? So over here, let's just go under this graph, divide this space in half. So you have room to write down both notations, but we are only going to talk about set notation to begin with. So write the words set up here and interval. We'll come back and do the interval notation. So we'll fill these in. Set and interval. Okay? I'll give you guys a moment to do that. Okay. All right. Now, just notice I didn't do it for this one here because this one's a different style graph. So we're going to only do one style for that one. All right. Over here. So let's get started here. Now, we want to talk about x values and y values. For x values, we use the word domain. So we use the letter D to say, okay, we're going to be talking about x values. This is the domain of the graph. Right? And for the domain of the graph, the x values, we give a range of values. What is the smallest it can be, which is the furthest left? What's the greatest it can be, which is furthest right? So looking on our graph, the furthest left, the lowest value of x is right here. Right? What value are we at there? -1. Right? So we put in a -1. Right? And next, we need to say what is the biggest value of x can be on for this graph. So going all the way to the right, that is the biggest value of x. We go over here. And what is the biggest value of x that can be? 3. Right? And that determined the range of values. X is between -1 and 3. Then we use brackets. Right? So we had square brackets and round brackets. And the square brackets we used for the solid dots. It means that point is included. The round brackets we used for the hollow dot. Right? On the left-hand side, we always used one of these open brackets. On the right-hand side, we used a closed bracket. So going back here, at -1, we have a solid dot, right? So that means we are using a square bracket here. Right? And then at 3, so we go to this side. At 3, we walk all the way around here, and we got the hollow dot, which means we're using the other style of brackets, the round bracket. Right? So that is it for writing down the domain, the x values. Right? So this tiny little notation here tells a lot of information. It says the domain, which is the x values, range between -1 and 3. We include the -1 value, but we do not include the 3. All that is in this tiny little piece of information. And you'll get better at reading that. Okay, now we're going to do the same thing, but this time talk about the y values. So for the y values, we write down R. That was for range. Okay, so we know we're talking about range now. And we do the exact same thing, but now, instead of looking at the x-axis, we look at the y-axis. So we go from the lowest y value to the highest y value. So lowest is at the bottom, and the highest is at the top. So what is our lowest y value for this graph?
-2.
Yep, -2. Then we go comma the highest y value. So go up to the top of the graph, +2. So we put down that 2. So we got the range of values here. It goes between -2 and 2. Now we just need to talk about the points. At -2, what kind of dot do we have?
Solid.
So is it a square or a circle bracket?
Square.
Square. So we put in a square bracket here. Right? And here, we've got a round bracket for the open one. So there we go. And that's it. Okay? So all we're going to do is talk about set notation. Once we've done all those examples, we'll come back and do interval. Go on to the next one. Now, this line, as the other line, is the exact same line as the previous ones. Has the same slope, same y-intercept. Only thing I changed was the dots at the end. Right? So our domain is still going to be between these points. So write this down. And our range is still between these 2 points. All we need to focus on is what kind of brackets do we need to use. Right? Because it's the exact same line. Has the same start point, same end point. All I want you to do is focus on the brackets. So looking at this, is it going to be a mixed match of brackets? Is it going to be all one type of brackets, Phoenix? It's all going to be the curved brackets, the round brackets, because both spots have the open dots. All right? So they're all going to be the curved bracket. All right. So let's go on to this one. Now, this is a similar line as the other one, but it has the arrow. So remember, the arrow means it just keeps on going on forever. So that has an effect on our endpoint. So I'm going to talk about the x values first. We start off with the smallest x value, which is over here. What number was that?
-2. Or wait,
No,
-1.
-1. Okay, comma the biggest x value. What is the biggest x value here? Max? Infinity, because this graph goes on forever. It doesn't stop, right? So we use the infinity symbol, which is a sideways 8, right? That tells us it's going on forever. Now, it's going on forever in the positive direction. You can also have negative infinity as well, if it was pointing downwards to the negative direction. So it's going off to positive infinity. So next off, we've got our numbers figured out. Now, all we need to do is the brackets. We have a solid dot, so it's going to be a square bracket. And infinity is interesting. What kind of bracket? We only have 2 brackets to choose from. Max?
Circle bracket.
The circle bracket. And why do you think it's a circle bracket?
Because there's no set point to it.
There's no set point for an infinity. You never get to it. It's an idea, right? So you can never achieve it. You're just always going on forever. So you'll never quite reach it. So you got to use the round bracket. Right? So square bracket and round bracket. Now you'd set up our range. Okay. We start off with the bottom of the graph, the lowest value.
-2 plus infinity.
Yeah, -2, and the graph goes up forever, so that will be infinity again. Okay, and it's a solid dot, so a square, and infinity gets the round. All right. Okay, we're going to skip the dots for now. We'll come back. Let's go to the back side of the page. Right? All right. So we're going to divide everything that has a solid line in half. So everything except for the top left-hand graph. And we're going to do set notation and interval notation for all of the set, interval, set, interval, set, interval, set, interval. Okay. All right. Did you guys do that?
I was writing an interval, not.
Interval. All right. Yeah. Okay. We'll start off with that circle. And we're going to talk about domain first, which is our x values. What is the smallest x value that I can have for this graph? Yes?
Negative 3.
Yeah. So the smallest x value is right here. That's the furthest left. So we put down a -3, comma. What is the largest x value we can have for this graph?
Positive 3.
+3 would be right here, right? The graph doesn't go that far.
One.
Thank you. +1, which is right here. Okay?
Would it just be square brackets if there's no?
Now, yeah, so now we have to decide between solid and square brackets. So we look at -3. Here, it's a solid line, so we can get to that point, right? So that would be a square bracket there, right? That value exists. And on the other side, we have a solid line here, so we can actually have that point on the graph. So once again, it's going to be a square bracket. Okay? Now let's talk about range. We start off with the lowest value. So working our way from the bottom to the top, what's the lowest value for y we can have? Phoenix?
-1.
Yeah, right here, -1. Then we continue our looking up and we go to the highest point. What is the highest point we can have for our graph? Gravir?
3.
3. That would be right here. All right?
And
Okay.
then square brackets?
And once again, since we can actually get to this point and get to this point, those are square brackets. Okay. Making a little bit more sense than last day?
Yeah.
All right? It was very fresh, especially right after the quiz. Last day it was a little difficult. Let's do this one. Domain, x values. What's the smallest x value we can have? Mikey?
-2.
Yep. The smallest x value is right here, which is -2. Let's do the bracket at the same time, so that after going backwards. So does -2 have a square bracket or a round bracket?
Square.
Square, because we can actually get to that value. That exists on this line. All right? On to the maximum side. What's the maximum value that x can have? Sorry? I heard it.
Infinity.
It is, because it goes on forever in the positive direction. All right? And with infinity, is it square or round?
Round.
Round, perfect.
And solid on the other side.
And solid on the other side, yeah. On to range. Okay. What's the lowest we can have? Sorry?
Infinity.
Close. Negative infinity. This is going down forever in the negative direction. So at the bottom of the graph, since it goes down forever, is negative infinity.
And then just infinity.
Yeah, and just on the top side, because it goes up forever, and that's positive infinity. Good, makes sense. Round brackets or square brackets?
All of them were round.
All of them around, good. So notice it's not necessarily a copycat of what the domain is for the brackets. You really do need to pay attention to what's happening at that point. Sometimes it's square, sometimes it's round. All right. On to this one. Domain. We're going to start off with the furthest left. How far left can we go?
-3.
Negative 3 would be here. No, the line definitely goes past negative 3 in this direction. Max? Yeah, because this line goes forever in this direction. So it goes forever negative. So we have negative infinity over here. Or like that, I want to say. And what kind of bracket does negative infinity get? Square or round? Round. Yeah, thank you. Okay, now we go to the right. What's the maximum value we can have? Kale? 2. Now, does 2 get a square or a round bracket? Sorry? Round. Because it's a hollow dot. Oops. Hollow dot. Right? That point is not included. Okay. Range. We're looking at the y values. What's the lowest it can be? Not none. Phoenix?
Negative infinity.
Yeah, because this line goes down forever. Right? So it doesn't have a bottom, it just goes down forever. So that it's never going to stop going downwards. So it's negative infinity in that direction. And the infinities always get the round brackets. Okay? Going the other way, what's the maximum value we can have? Yes, Kale? 4. We're looking for the highest value, not necessarily the end point of this line, right? So don't confuse the two. We're looking for the highest in this direction, so that's 4. Square bracket or round bracket? Square. All right. There we go. On to the next one. We have domain starting off first. The x values for domain. How far left can we go? To negative 5. Thank you. And does negative 5 get a square bracket or a round bracket? Square, because we have a dot here. Right? By the way, I hand draw these graphs, so if the dot doesn't look perfectly on a square, it's meant to be perfectly on a coordinate thing. I'm not going to give you decimal stuff for this. So these are all hand drawn by me. Okay, we go to the right. How far right can we go? 2, 4. Thank you. Right here.
And that's a circle.
That's a circle one. It's an open hole here. And that, we can never quite achieve it. So it's a round bracket. Nicely done. I like the fact the frustration levels have gone down. Okay, range. What is the lowest? We're going from lowest to highest. Gravir.
Negative 4.
Yeah, so range, we're looking at the lowest value, which is right here, which is at negative 4. And does negative 4 get a square or circle bracket, a round bracket?
Square.
Square, that, it's a solid dot.
And then it's 1 on the other side here.
Then you say it's 1, right? 1 would be right here. Is that the highest the graph can go? Go to 2, right? So you can go all the way up to there. Now, does 2 get a square or a round bracket? Oh. So 2, we're referring to which dot? We're referring to the highest point, which is this point here, right? So that is a hollow point. It's round. Okay. This one. So domain. How far left can we go? Infinity. Is this direction infinity? Negative infinity. It's in the negative direction, right? So negative infinity. And infinities get round brackets always. How far do we go in this direction? Infinity. We have those arrows. They go on forever. All right. On to range. What do we have for the range? What's the lowest value that our range can be?
1.
Jack? Sorry?
1.
1. What is the highest value our range can be?
1.
1. So our range is just one number. Now, does that one number get circle brackets or square brackets?
Square.
Square, because it can actually equal the value of 1. Right? So we get square brackets. Right? The range consists of only one number. Okay. So that is all the different variations I could probably throw at you for set notation and these kind of graphs. Right? Now we're going to go for the interval notation. So go back to here. We're going to do the whole thing with interval notation now. Right? So one thing to note is our boundaries are always the same. Right? If we said this domain is between -1 and 3 in set notation, that's not going to change for interval notation. Right? Only thing that's going to change is how we communicate. So to start off with, we're going to do that little d first. And we're going to put down -1 and 3 widely spaced apart. We're going to keep the boundaries the same as we did before. That's not going to change. It started here, went to there. Right? And with domain, we throw in the axes that we're referring to. We're referring to the horizontal axis, which is x in this case. So we put that in. Right? And then we use inequalities instead of brackets to communicate that the numbers fall between these. Right? So x is always going to be bigger than -1 and always going to be less than 3. Right? That's how you say in between two things. So you're always going to put in, if you keep this method, arrows, equal sign, inequality symbols like this. X is bigger than -1. The mouth opens up to the bigger one. X is less than 3. Okay? So if you keep this notation, it's always going to be pointing this way. The only thing you have to really think about is, do you include the little line underneath? Because that means equal to. So if you have a solid dot, we can actually equal this point. Right? So we put a line underneath it. So at -1, we had a square bracket and a solid dot. So we put an extra little line underneath here because x can be bigger than -1, but also equal to it. Okay? You see that? Because it's a solid dot. It's actually can equal -1. Now on the other side, we have a round bracket, right? And x can never equal 3 because it's a hollow point, so that just stays as is. No line. Because the line means equal. Right? And that's it.
You say with infinity, it would be no line.
Same thing with infinity. Good thinking ahead, yeah. Because you can never equal it. Okay, so now let's do the same thing for range. Right? Our boundaries don't change. So when we're doing these, I strongly suggest that you do set notation first. Then when you're setting up your interval, just take the same numbers. Spread them further apart. Put
Two arrows always face this way.
always face that way. If you keep it this way, they're always going to face this way.
So there's never a time where they go in different directions?
If you don't follow this format, they could go the other way. We can talk about that later on, but for this purposes, I just want to set up in this format. Less issues to worry about. So now we have it set up like this. We just need to decide whether or not to put that equals line in. For -2, we have a square bracket and a solid dot. Do we include the equal line?
Yes.
Yes, square brackets get the equal line because it has the round solid dot. At -2, we have a solid dot. At +2, we have a round bracket and a hollow dot. Do we include the equals or not? No. And that is it for your range.
How come the other one over there had a line under it?
Which one?
The,
Previous one when we were talking about it?
yeah.
Because that one was a solid dot.
Oh, okay.
Right? So the graph changed a little bit. Okay. Set up the next one. Right? Domain, dot, dot. Spread out your endpoints. Put in the x. Hey, might as well do the range at the same time. All right. Okay. You got them spread out. You put your inequality symbol in. The alligator was always opening to the right. Put that in. All you have to decide is whether or not you need to include the equals part.
They all have no lines.
They all have no lines, says Ilana, and she is correct because these are both open circles, right? So that's it, okay? So x is always going to be bigger than -1, but can never equal it because it's an open dot. And x is always going to be less than 3, could never equal it because it's an open dot. That's all that says. And they exist everywhere else in between. All right. Next one. We're going to set them up the exact same way. -1, space, x, space, infinity. -2, y, infinity. Keep our boundaries exactly the same. Throw in the inequalities. And we just need to decide whether or not to include the equals line. Okay? So, looking at
The one on the left has a line.
-1, equal sign? Yes. Square bracket, solid dot, equal sign. Infinity?
That one doesn't.
Doesn't. -2?
Yeah.
Yeah, square bracket. Infinity doesn't. Now, that's your domain and range. Now, if you were using a textbook, you would see the answer doesn't look quite like this. Because in interval notation, it's sort of not the proper practice to include infinity in your writing. So we could just go like this and cancel this out. It means the same thing. X is always bigger than or equal to -1. There's no need to include that infinity, right? X is always bigger than -1. You don't have to say between infinity because this stays the same. X goes on forever. Same thing over here. We don't need to include this infinity. Is saying this is the same thing. Y is always bigger than -2. It goes on forever that way. There is no boundary over there,
So what happens with the circle on the back page?
right? That one, the circle one, has definite boundaries. We'll get there. All right, so let's go over here. Back to, is that fine with crossing out to infinity? We just don't need to show it. All right. So domain, range, copy the same numbers. Just put the variable in between.
Wait, they would have a line underneath because it
Well,
goes to a certain
just
point.
give people a second. Give people a second. You're on the right track. You're understanding this. Good. Okay. So, square bracket, solid dot, include the equal sign. Round bracket, hollow dot, no equal sign. Give you guys a millisecond here to decide whether or not you include that equal sign there or not. Right? All right. -3. Do we have an equal sign?
Yes.
Yes, we have a square bracket, solid. We throw in the equals. 1. We have a square bracket and a solid line. What do we include the equals?
Yes.
Yes. There we go. Range, -1. From here. Yes. Thank you. Square bracket, solid line. Include it. Y, 3. Yep, square bracket. Good. Easy. Huh? Just keeping it straight in your head. That's what it's going to look. Okay.
So we don't show infinity?
On interval notation, we don't show infinity. I won't mark you incorrect But I want you to get into the good habit for next year because you'll be doing this.
Range just be.
Oh, we'll get to the range one. All right. So let's talk about domain. So let's talk about range. You fill in the stuff. Remember, you can put infinity in, but I suggest not including it. Okay. So let's talk about domain first. So we're going to avoid the infinity for the -2.
There is one.
There is a line, right? Because it's a square bracket, solid point, include the line, and it goes on forever. So negative x is always bigger than or equal to -2.
And then we just don't do the infinity one.
Now, the range is, we can't, if we don't put infinity in our notation here, like what do we write down? We can't write down nothing, right? Because it does have something, right? What we say, instead of saying negative into infinity, is the phrase, all the real numbers. Okay? All real numbers. So that's a way of saying negative infinity to infinity. Okay? And when you get to university, if you're doing some math stuff or science stuff in the future, you'll learn about non-real numbers. We call those imaginary numbers. So there are some things other than real numbers as well. All right, so that's what we say for negative infinity to positive infinity. All the real numbers. Okay? Okay, let's do this one. Domain. Range. So do it in the same order you see it. Okay, infinity is here, so we're going to skip the infinity part. We can put the x in, then we can put the 2 in. We're going to skip the infinity part, put the y in, put the 4 in. If you do it in the same order, you don't have to worry about what way does that inequality mouth open. It always opens to the right. If you start mixing the orders around, then you're going to have issues with which way the mouth opens. You can still do it. You just have to do one extra step of thinking. Okay? So, domain, the number 2. Do we include equals? No. We have a round bracket and a hollow point, no equals. The 4. Do we include the equals line?
Yeah.
Yep, there we go. Easy?
Yeah.
Nice. All right. Do the next 2 yourself. Give you guys a head start, and I'll write up the answers. I'm going to freeze this.